So let's have a quick look. Today I want to zip through something really simple. Then I'm going to let you do your choice. You can either finish up chapter 5 test, retake chapter 5 test, you can finish up essential skills, you can do lots of things. You can work on homework, I'll leave you to your choice of your Friday fun math activities. They're all great fun, so you can pick. So what's it mean to be a quadrilateral? Four-sided polygon, right? So we're going to start looking at, and this will be quick, we're going to start looking at, let's put all phones away, please. All phones away, completely away. We're going to start looking at some properties of quadrilaterals. Okay, and we're going to start off with a pretty basic one. We're going to start off with a parallelogram. So tell me, what do you suppose, and I know you've talked about this in the past, what do you suppose the definition of a parallelogram is? A quadrilateral that has what? Has what? Okay, has two pairs of parallel sides, right? How would I indicate that on my picture? Okay, with the arrow things, exactly. So, like that, right? Something like that?
Yeah.
Okay, there are four sort of important properties of parallelograms. What do you think they are? What do you think is always true for parallelograms? Name one thing. Help.
That the parallel sides are equal.
Are congruent, right? Okay, so we could say a parallelogram, the opposite sides in a parallelogram are congruent. That's one thing that's true, okay? So we could add those congruence marks. Something else.
Opposite angles are congruent.
Opposite angles are congruent. Very good. So we could do this. We could say that that angle is congruent to that angle, and that angle is congruent to that angle. Now I'm going to label the vertices here because we might need it.
Do all angles, like all the angles added up, do they equal 60?
Yeah, they do. Right, they do that. In every quadrilateral, they would some of the interior angles is 360. But I'm not going to put that up there because that's for all quadrilaterals. I want stuff that's only true for parallelograms, but not in general. So somebody else, something else you think? We got the easy ones. Now we need a little harder one. Any suggestions? And just take a guess. You probably don't know, but I mean, what do you anyone want to suggest something that looks like maybe it's true? Nothing to give us something else?
Angle D and angle C are supplementary.
Okay, yeah, that's true. So we also know that consecutive angles in a parallelogram are always supplementary. Okay, that's always true. So if I walk around the outside and I hit any two angles in order, they're guaranteed to be supplementary. Okay? And one other thing, what do you think, Joe?
It's symmetrical because we don't have to do both ways, right?
Say it again?
It's symmetrical if we cut one.
Okay, it's, are you sure?
If you flip one over.
Cut it this way.
Cut it which way?
Horizontally.
Like this way?
Yeah, then you flipped it.
And then like, she's saying like you
Folded it.
Flipped it and rotated them? Okay, that's true.
Oh.
But it actually doesn't have line symmetry, does it?
No.
Right? I mean, that's not something we were planning on talking about, but line symmetry would mean, could I fold it over a line and have it line up perfectly? And it doesn't, does it? Okay, this is a quadrilateral that does not have line symmetry. Does it have rotational symmetry?
Yes.
It does. I could put a tack in the exact middle and spin it 180 degrees and it would line up, right? Okay, so it does have that stuff. So we've got, if we just summarize these, we've got a couple things. We knew one, opposite sides are congruent. Two, opposite angles are congruent. Three, consecutive angles are supplementary. The last one's pretty tough. Any ideas? I'll give you a hint. I would have to add some additional segments in here to the picture to demonstrate this. Okay, kind of. How would I draw the triangles? Okay, so, okay, I'll add the diagonals, good. What if I add the diagonals? So if I go, what if I go from there, up to there, from there, up to there? Okay, what do you think is true about the diagonals? Gabe, what do you think? See anything? Any suggestions?
The two pairs of triangles are congruent?
That ends up being true. Ends up being true. That's not technically on our list. It's kind of something we could prove from our list. But the last part of our list only really involves the diagonals. What do you think is true about those diagonals? Well, they're not necessarily the same length, because if I exaggerate this, what if I had a triangle that, or a parallelogram that looked like that, right? Then I'd have a pretty short diagonal and a pretty long diagonal, but something's true. Kirk, what do you think?
It's often that, like they intersect into that.
Okay, so they intersect. Well, I'm going to change that very slightly. The intersection of the diagonals bisects both of those segments. So in other words, the diagonals, to make that, we could say that more easily and simply, we could just say the diagonals bisect each other, right? So if I look at this point right here, it's going to be the midpoint of both diagonals, right? So this would have to be true, and that would have to be true. Okay? Make sense? Okay, so I'm going to, in this chapter with quadrilaterals, we are going to do, I'm going to have you do some, get back to a few proofs. I've extended the list of reasons. I added all the chapter 5 stuff that we did, and I think we're up through section 6.2. I'll put those up on the site. I'm going to add the 6.2 assignment real soon. 6.1 is up. You've got tests to do. You've got essential skills. If you want to finish that up, you can. Everybody's probably got something to do, right? Yes? Okay. Let me see if I get the Chromebooks. If I can, I'll bring them down. Otherwise, we'll go to 11.